Hello, my Algebra 1 students. We're in lesson 48 and we're going to introduce some terms. We have talked about each one of these in our work so far, and we see each of these and we've been calling them terms. We've also called a few of them binomials. I just want to go over these specific terms. Every one of these is what we would consider a polynomial. A polynomial just means many terms. Okay. It is a real number, a whole number, a rational number. All right. Underneath the category of polynomial, which means many, or a variety, it's actually more closer to a variety than many, we have a term called monomial, which means one. Mono means one. Monomial means one term. So this is a monomial, this is a monomial, this is a monomial, and this is a monomial. Then we have what's called a binomial. Bi means two. So two terms. This is a binomial. This would actually be a monomial because it's a fraction. This is a fraction, a monomial containing a binomial numerator. And this is a binomial. Then there is another called the trinomial. And we know that tri means three. So bi means two, tri means three. We have a trinomial right here. We could also call this a trinomial because we have 1, 2, 3 terms that consists of a binomial in the numerator and a monomial in the denominator. So these are just some words that we might use in class, and I want you to know what they mean when I say them. When I say this trinomial needs to be factored, I want you to go, she just means that expression with 3 terms in it is a trinomial. Okay? That's all that the lesson 48A is all about. It's just introducing this terminology so you understand as we go forward when we use these big words to represent these things here. So write down these words, these terms, and what they mean. Many means, instead of many, think of it as variety, V-A-R-I-E-T-Y, a variety of terms. Okay, you have an assortment or a variety to choose from. And these are all polynomials because this is an assortment or a variety of terms. All right, so I'm going to clear the page. Pause if you need to. So let's move on to degree. If I have a list of terms here, let's say I have 4x cubed plus 2x minus x squared. The degree of an expression, in this case we have a trinomial, the degree of an expression is the highest exponent that is listed or given. And in this case, the highest exponent is a 3. So this trinomial could be said to have the third degree. We have a third degree trinomial is what this is. All right. If I had 4b to the 6th plus y squared I would say this is a 6th degree, not 60, Tracy, 6th degree binomial because there's only 2 terms here. If I had 7y to the 5th, I would say this is a 5th degree monomial. Right? Do you see how that works? It's really pretty self-explanatory. It's just whatever the biggest exponent, and they don't even have to be the same variable. You're just looking for the highest exponent. That determines the degree. The number of terms determines whether or not it's a trinomial, a binomial, or a monomial. But even then, I could turn around and say that this one is a 5th degree polynomial and still be right. So all of these are called polynomials. We're just being specific in our count when we use these words here, and the degree is just the highest exponent that is used. Easy peasy. All right, so let's move on to the addition of polynomials. So let's say I have this set of problems here. This is 48.1. And I have a trinomial that I'm adding to a binomial. And here's the trinomial. And it is x cubed plus, let me rewrite that so you can see it, plus 3x squared plus 2 plus 2x cubed plus 4. So the first thing we want to do is we want to break it out of the parentheses and write this in descending order, which means we put it in exponent order, highest to lowest. So descending order would be with all of these written outside of a parenthesis. So we're going to take x3, and then we're going to take, let's cross that out, then we're going to take 2x3 plus 2x3. And before you take it out, make sure you look at this sign. If it's a positive sign, nothing changes. If it's a negative sign, you have to take the opposite of whatever this is. But because it's the same, it's a positive, it stays the same. All right, now we're going to take our x squared. We don't have another x squared. We don't even have another x. So now we just put our constants, our whole numbers together. Now we can combine like terms. So there's an invisible 1 right here. That's going to be 3x cubed plus 3x squared plus 6. That's as far as we can go. And we have just added these two polynomials together. It's that easy. All right, let's look at another one. 48.2. All right, we have this trinomial, 3x to the 4th minus 2x squared plus 3. And that's going to be minus x squared minus 7x minus 5. All right, I'm going to show you a trick that you can use if it helps. If you don't like it, don't use it. You do this. But here's what you can do. It's called stacking, and we'll use it later when we start multiplying polynomials by polynomials. So the first thing we're going to do is we're going to start with the highest degree, which is 3x to the 4th. And then we're going to look for our next degree, which would be to the 3rd. We don't have one. So let's get rid of that one. Negative 2x squared is our next highest degree. And you want to write these in ascending order from highest, or descending order from highest to lowest. And I'll show you why in a moment. All right, so we have that one. Now we have an x squared here, but we have a negative in between. We have a minus. We're going to put a 1 here. going to say negative 1 times x squared. That's going to be negative 1x squared. Now we've gotten rid of that one. All right, now we have an x. So let's write negative 7x, but it's times a negative 1, so that makes it a positive. Now we don't have another x term, but we do have a positive 3. And we have negative 1 times a negative 5. That's going to be a positive 5. Now this stacking method allows me to draw a line and say 3x to the 4th minus 3x squared plus 7x plus 8. This is a way that you can do this that just kind of organizes your numbers a little bit better. It's entirely up to you if you want to use it. This is just a little bit of extra so that whenever you come across a term, you can stack it under the one it matches, and then you can add like terms a little bit easier. It's just a shortcut that organizes your numbers for you. And then when you get your final answer, it's all in the right order and it's all arranged properly in descending order from the largest exponent to the smallest exponent. Now I want you to keep in mind that when we have a whole number together, we consider this to still have an exponent, but the exponent is x to the 0, which is just 1. 1 times 8 is still 8. So even though there's no variable there, we still consider this to be the degree of 0. This is the degree of 1. This is the degree of 0. All right, so we include that with our exponent list for that reason. Let's do one more. Let's do 48.3. Let's do it right here. Let's see what we have. Let's see. We have, you know what I did? I took part of one problem and put it with another. So we're just going to do the opposite. So if I have 3x cubed plus 2x squared minus x plus 4 here, and I want to subtract this trinomial of x4 minus 2x cubed plus x squared. I'm going to use the stacking method just for the sake of organizing all of these numbers. So I'm going to start with my highest exponent, and that's x4, but I have a negative 1 right here. Negative 1 times x4 is negative 1x4, right? So cross that one out. Do I have any more x4s? No. I have a 3x3 and it's positive. So positive 3x with a 3. Do I have another 3? I do. It's a negative, but I have a negative 1 times negative 2. It's going to be positive 2x cubed. All right. Now, do I have x squares? Yes, I do. I have a positive 2x squared. And I have a positive x squared, but I have negative 1. Negative 1 times positive x squared is a negative 1x squared. See how I'm keeping the 1 in place? So it's going to make it easier for me to do my math later. So now I can cross that one out. Let me cross that one out too. I used it already. So now I have an x to the 1. It's a negative x to the 1. I'm going to write it right here. Get rid of that one. And I have a whole number 4 left. So I'm going to write it right here. Now I can draw my line. This is a 2. And I'm going to combine. So I have when I do this, I'm going to drop my 1. This is a negative x to the 4th plus 5x cubed plus x squared, because 2 minus 1 is 1. I have my invisible 1. Minus x plus 4. And that would be my answer. All right, and you can see how stacking helps you to organize just a little bit better. So you're not having to rewrite it every time you come across another one of those numbers. Let's say you're doing this and you accidentally skip over. Let's do one where we do that. Let me move this page up here. Let's do 48.4. All right, and we have 3x to the 5th plus 2x squared plus x minus 3 minus 4x to the 4th plus 2x to the 5th minus x squared plus 7. All right, that's a nice long one right there. All right, let's say we're going through here and we write, all right, I have 3x to the 5th. All right, and I have a 4x to the 4th, but it's negative 1 times that. So it's negative 4x to the 4, okay. Let's do, all right, I have an x squared, so plus 2x squared. All right, I got that one. I have a positive x, so plus x minus 3. Oh, wait, I have another 2x5. Negative 1 times positive 2. That's negative 2x to the 5th. Because I stacked it, it was easier for me to add this in after the fact. So now I can put my positive 1x squared right here. And then I can put my negative 7 right here. And now I can add or combine. So I'm going to have a 1x to the 5, a negative 4x to the 4, a positive 3x squared, a positive x, and a negative 10. And the stacking is just a little bit easier for me to say, to add a number in if I've forgotten it. If I didn't catch all of my 5s at the same time, I can add them after the fact. The important thing you want to do is not skip. Like if I find a 5 and x to the 5, the next thing I want to look for is x to the 4. And then I want to look for x to the 3. If I don't have any, that's fine. You just want to make sure you keep a place for all of them. Okay? All right, so that's all we have for lesson 48. That's literally it. So I will see you guys in lesson 49. If you have questions, please message me. I want to help you.